Hello dear students, welcome to the new session of class 9 physics chapter gravitation part 1. Dear students, in this session we are discussing about the gravitational force. Okay, let's begin. What do you mean by gravitation? The earth attracts all the objects towards its center. This attracting force provided by the earth is called gravitational force. Clear? Some examples are given here. In the first case, you can see that a body is releasing from a certain height. So, this body is coming down or moving towards the earth because the earth is attracting this body. In the second case, a person is walking, and here the friction force and the gravitational force which helps the person to walk either direction. Clear? In the third case, if we throw a ball upside, after reaching certain distance, the ball come back because of the attraction of the earth. Clear? Yes. Actually, this gravitation is invented by a great scientist called Sir Isaac Newton. Okay? Yes. Then what do you mean by universal law of gravitation? The universal law says that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Once again, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Clear? Okay, let's discuss this law in detail. For that, you just consider two bodies, body A and body B. Body A has mass m1 and body B has mass m2. And these two bodies are separated by a distance r. Clear? Yes. Now, according to the universal law of gravitation, the first part of the law says that the force is directly proportional to the product of their masses. Therefore, F is directly proportional to the product of masses m1, m2. It can be taken as equation number 1. Then second part of the law, the attracting force which is inversely proportional to the square of the distance between them. Therefore, F, the force inversely proportional to the distance 1 by r square, can be taken as equation number 2. Clear? Combining equations 1 and 2, then you will get what? F is proportional to m and m2 by r square. Just combining these two equations. F is proportional to m and m2 by r square. Equation number 3. Clear? Yes. Then here we used a constant called g. Why we are using constant? To remove this proportionality sign. Clear? For that we used a constant called g, and that g is known as the universal gravitational constant. Therefore, the equation which becomes the gravitational force F is equal to g m and m2 by r square. And this expression is very important, and this equation is needed for the mathematical calculations. So you should study this equation. Clear? Yes. Then the value of g does not depend on the medium between the bodies and masses of the bodies. So it's an important point. The value of g does not depend on the medium between the bodies and masses of the bodies. Clear? Yes. So I have already told you that Newton who invented this gravitation, therefore this universal gravitational law is also known as Newton's law of gravitation. Clear? Then what is the SI unit of G here? The SI unit of G is Newton meter square per kilogram square, or you can write like this. Both are correct. How this SI unit is obtained from this equation? For that, you just rearrange this equation as G is equal to r square by m and m2. G is equal to F into r square by m and m2. Then what is the SI unit of force? Newton. What is the SI unit of distance? Meter. Here it is r square, therefore meter square. Clear? Then what is SI unit of mass? Kilogram. Here two bodies are there, therefore kilogram square, and the unit is Newton meter square per kilogram square. Clear? Yes. Then value of G is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square, and this value is also very important for the mathematical calculation, so you should study this value also. Clear? Yes. Next, what is the relation between the universal gravitational constant and the gravitational force? Relation between F and G. So numerically we can write F is equal to G. How? So we know that it is what we call the gravitational force. F is equal to G m1 m2 by r square. And in this equation, we just give m1 equal to m2 equal to 1 kilogram and distance r is equal to 1 meter, which means this entire quantity which becomes 1. Therefore, F is equal to G. F is equal to G means gravitational force is equal to the value of gravitational constant. That means F is equal to 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. Clear? Therefore, we can write F is equal to G. So, what one you are getting from this equation? Here we can see that the power is 10 raised to minus 11, right? Which means what? The force is extremely small force, right? Yes, which means what? The extremely small value of gravitational constant tells us that the force of gravitation between any two ordinary objects will be very weak, which means in the universe each and every body attracting each other, but you cannot see their attraction because this force is very weak. Clear? Yes. So in the next class we will discuss the chapter in detail. Till then, bye. Thank you so much for watching video.